From the dawn of civilization, gold has captivated the human imagination. Unlike other metals that rust, corrode, or lose their luster, gold is incorruptible. Its glow is timeless, unaffected by centuries, immune to decay. Ancient Egyptians considered it the flesh of the gods. The Incas called it the sweat of the sun. Across Asia and Europe, kings measured their wealth in gold and adorned their crowns with it, while empires rose and fell over the control of golden mines. But beyond its beauty and rarity, gold became a symbol of power and immortality, something eternal in a world where everything else crumbles. Naturally, humans began to wonder, if gold was perfection, could one learn to make it artificially? Could lead, the symbol of decay and worthlessness, be transformed into gold, the symbol of eternity and purity? This question gave birth to one of the most enduring mysteries in human history, the dream of turning anything into gold. From medieval alchemists whispering about the philosopher's stone, to modern nuclear physicists firing particles at atoms, this quest has stretched across centuries. And while the answer is not simple, it is more fascinating than any myth. Alchemy began thousands of years ago, blending mysticism, religion, philosophy, and early chemistry. In Egypt, China, and India, alchemists believed all matter was composed of fundamental essences that could be reshaped. By the Middle Ages in Europe, this belief had evolved into the pursuit of the philosopher's stone, a mysterious substance said to hold two ultimate powers, the ability to turn base metals into gold and the power to grant eternal life. Lead, with its dull heaviness, was seen as a young or imperfect metal, still in the process of evolving into gold inside the earth. Alchemists thought they could accelerate this natural process. They mixed mercury, sulfur, and salts in secret furnaces, distilling, melting, and recombining substances, hoping to find the right recipe. For them, the transformation was not only physical, but spiritual. Just as base metals could be purified into gold, so could the human soul be purified into enlightenment. Even Isaac Newton, remembered today for gravity and calculus, wrote over 1 million words on alchemy in his private notebooks, convinced there was hidden knowledge in ancient texts. Nicolas Flamel, the Parisian scribe later mythologized in Harry Potter, was said to have discovered the stone and created vast wealth. Though no alchemist succeeded in making gold, their work contributed to the birth of chemistry, metallurgy, and the scientific method. By the 17th and 18th centuries, the age of alchemy gave way to modern chemistry. Antoine Lavoisier, often called the father of chemistry, proved that matter is made of elements that cannot be destroyed or created by chemical reactions. The dream of alchemy collapsed under this new science. In 1869, Dmitri Mendeleev organized the periodic table, showing that each element is defined by the number of protons in its nucleus, the atomic number. Lead has 82 protons, gold has 79. To change one into the other, you cannot heat, mix, or distill. You must alter the nucleus itself, removing or adding protons. But this requires energies millions of times greater than those of chemical reactions. Alchemists were playing the wrong game. They tried to use chemistry to solve a nuclear problem. It was as if they tried to carve granite with a feather. Only with the rise of atomic physics in the 20th century did humanity gain the tools needed to attempt real transmutation. In 1919, physicist Ernest Rutherford bombarded nitrogen with alpha particles, transforming it into oxygen. This was the first artificial nuclear reaction, proving that one element could indeed be changed into another. Soon, the discovery of radioactivity revealed that some elements naturally decay into others, with uranium eventually becoming lead over billions of years. Scientists realized that if nature could transmute elements, perhaps humans could accelerate the process. With the invention of particle accelerators and nuclear reactors in the 20th century, for the first time, humanity had the power to manipulate the nucleus of atoms. The alchemist's impossible dream was suddenly possible, at least in principle. Let's look at the challenge scientifically. Gold's nucleus has 79 protons, lead has 82, mercury 80, bismuth 83. To create gold from lead, one must remove 3 protons. From mercury, remove 1, from bismuth, remove 4. This can be done by bombarding these nuclei with neutrons or protons at very high energies. When a neutron hits a nucleus, it can cause it to emit a proton, changing the element. Alternatively, accelerated ions can smash into the nucleus and knock protons out. This process is called nuclear transmutation. The difficulty lies in the stability of the products. Many artificial isotopes of gold are unstable and radioactive, decaying quickly into other elements. To get stable, usable gold, gold-197, the naturally occurring isotope, We need not just to knock protons away but to do so with surgical precision. The probability of this happening in controlled conditions is extremely low, requiring immense amounts of energy for tiny yields. In 1980, Nobel laureate Glenn Seaborg, who had previously discovered plutonium and worked on the Manhattan Project, decided to test whether humans could really make gold. Using a particle accelerator at Lawrence Berkeley Laboratory, he bombarded bismuth-209 with carbon and neutrons. The reaction stripped protons from the nucleus, creating isotopes of gold. Seaborg had done it, alchemy was real. But the gold produced was microscopic, detectable only by sensitive instruments. It would have cost millions of dollars to produce a fraction of a penny's worth of gold. Seaborg himself admitted it was impractical. We've shown it can be done, but it will never be a way to get rich. Still, the symbolism was profound. After thousands of years of failure, humans had finally accomplished the alchemist's dream. Mercury is tantalizingly close to gold, with just one proton difference. In the 1940s, scientists bombarded Mercury with neutrons, producing gold isotopes. However, most of the resulting isotopes were unstable, decaying quickly. A few were stable, but again the quantities were microscopic. Even today, researchers acknowledge that while we can make gold from Mercury, the cost is hundreds of millions of dollars per gram. To produce 1 ounce of artificial gold would cost billions. From an economic standpoint, artificial gold is worthless. From a scientific standpoint, it is priceless because it proves transmutation is real. To understand why making gold is so inefficient, we need to consider nuclear binding energy. Protons and neutrons are held together in the nucleus by the strong nuclear force, one of the 4 fundamental forces of nature. Overcoming this force requires immense amounts of energy. Energy on the scale of particle accelerators like CERN's Large Hadron Collider, which costs billions to operate. Even then, the probability of producing stable gold is tiny. It's like throwing darts at a target the size of an atom while blindfolded, with most of the darts missing or hitting the wrong spot. The yields are so small that even if you devoted the world's largest accelerator to gold production, you would end up with less than a gram after decades. Mining gold from the Earth's crust where it naturally occurs is millions of times cheaper. If it is so hard for us to make gold, how does nature produce it in abundance? The answer lies in the most violent events in the universe. Stars fuse hydrogen into helium, helium into carbon, and so on up to iron. But fusion beyond iron consumes more energy than it produces. Heavy elements like gold require environments with extreme neutron fluxes. This is where the R process, or rapid neutron capture, comes in. During a supernova, when a massive star explodes, or a neutron-star merger when 2 ultra-dense remnants collide, enormous numbers of neutrons flood into space. Atomic nuclei capture these neutrons faster than they can decay, building heavier and heavier elements. In a fraction of a second, elements like gold, platinum, and uranium are born. In 2017, the neutron-star collision detected as GW 1708-117 provided direct evidence. Astronomers observed light from the event containing the spectral signatures of heavy elements, including gold. Estimates suggested that several Earth masses of gold were created in a single collision. This means that every piece of gold on Earth, from coins to wedding rings, was forged in cosmic violence billions of years ago, long before our sun was born. Suppose future technology makes it cheap to turn anything into gold. What would happen? The value of gold would collapse overnight. Its economic power lies in its rarity. If every nation could flood the market with tons of artificial gold, it would become as common as steel. Historically, gold-backed currencies relied on the assumption that gold was finite. Artificial production would destroy that foundation. In this sense, the impossibility of making gold in bulk preserves its value. Gold's beauty comes not just from its luster but from the fact that it cannot be created at will. In the end, the dream of turning anything into gold tells us more about humanity than about gold itself. For alchemists, it symbolized spiritual transformation. For physicists, it represents mastery of the atom. For the universe, it is simply the byproduct of catastrophic explosions. Gold is precious not because we cannot make it, but because it reminds us of the scale of the cosmos. The gold in your jewelry traveled across billions of years, born in the death throes of stars, carried by cosmic dust, trapped in the rocks of a young Earth, and finally dug up by human hands. The real treasure is not the metal, but the knowledge that we are connected to the universe at its most fundamental level. The mystery of turning anything into gold has carried us from mystical laboratories filled with cryptic symbols to the most advanced nuclear facilities on Earth, and finally into the heart of neutron stars. The journey shows how human curiosity can transform superstition into science, and myth into understanding. We cannot fill our pockets with transmuted gold, but we have gained something far more valuable: insight into the workings of matter and the universe. In a sense, alchemists were right. The true philosopher's stone does exist. It is knowledge, curiosity, and science itself. That is the stone that turns ignorance into wisdom and base dreams into golden truths. So, can we turn anything into gold? The answer is yes. In the lab, through nuclear transmutation, but at a cost so enormous it makes no sense. Alchemists searched for centuries in vain. Modern physicists have achieved it, but only as a demonstration. The universe itself performs this miracle every time stars die or collide. The gold we treasure comes from events more powerful than anything humans can imagine. Thank you for joining me on this journey into the mystery of gold. If this video fascinated you, please tap the like button, subscribe to Beyond X, and ring the notification bell so you never miss another deep dive into the mysteries of science and the cosmos. Together, we'll keep searching for the true treasures of the universe: knowledge, discovery, and the eternal light of understanding.